Hello and thanks for coming in and welcome to the Adroit Technologies webinar series. Today I'll be showing the GOC35 hardware unit, which is basically a PLC and HMI solution. This presentation will consist out of two parts. Part one will be the set of functions and features and how to get started with the product. And part two will be a demo, which will show the user how to achieve some of the requirements. This video will be uploaded onto the YouTube channel and will be available for download after the presentation. Once the presentation starts, the live chat will be disabled, and if you've got any questions, you are free to email it to us and we will get to it progressively as we receive them. Okay. So part one of the presentation, as mentioned, is a short summary of the product functions and features. In short, this unit has two functions, which is combined into a one unit, a single unit. Okay. It's got a PLC function used for basic and standard PLC programming. It's also got a HMI function, which consists out of an LCD display and embedded illuminated keys. I want to point out that this LCD display is not a touchscreen, and if such a functionality is needed, then a proper guard needs to be applied. Okay. So basically this unit is ideal and catered for small automation requirements, such as standalone machines, simple and small processes, and equipment like that. It's not intended to replace a IQF and GOT simple combination, especially when it comes to advanced functionality. However, if the system applicable does not require advanced functionality, then this unit is ideal for such applications. Okay. As for the communication protocols for this unit, there's two main streams, the Ethernet standard and the serial communication standard. The Ethernet standard accommodates two communication protocols of industrial standard, mainly Modbus TCP and CC-Link IE Field Basic, which is of course the Mitsubishi proprietary communication protocol. For the serial communication standard, RS-232 and RS-485 is being accommodated. Now, the GOC consists out of three parts. The main unit, as mentioned, consists out of PLC and HMI. In addition, I/O extension units can be added on top of this PLC function of this GOC to expand the I/O functionality of this device. These can be digital discrete IOs, analog continuous IOs, and also high-speed inputs. Okay. They are optional. And then the third part will be the communication extension units or add-ons. So these can be Ethernet or serial, as mentioned, and at least one of them is required to program this device, GOC. The Ethernet communication port, of course, is the recommended of the three. Once the Ethernet communication card is added to the HMI, you can use the built-in configuration tool, which is called the system menu, to configure the Ethernet communication ports. It is run via the hardware firmware, and it's used to set up multiple of hardware properties. In this particular case, we will only be interested in the Ethernet communication properties like the IP address and subnet and default gateway for the scope of this presentation. As can be seen, the GOC can accommodate two communication cards to be connected to a PC or another device. in this case to a laptop for programming purposes, Ethernet and the serial communication port. Note that if you opt for a RS-232 serial communication port, you will need an additional serial to USB converter to accommodate the programming process if your PC does not have a RS-232 communication port. As such, the Ethernet port is once again the recommended option. Here's an example of the Ethernet communication card, which is applied to the GOC, in this case for programming purposes. And as you can see, the communication slot on top here is still available and open for a serial communication card to be added. We won't need this at this stage. So once you apply this Ethernet communication card, you will need to access its settings via the system menu. So to do that, you have to press the left arrow key, give it a long press. After a couple of seconds, 3 to 5 seconds, the system menu will open and will allow you to navigate towards the IP setup. It's here where you can set the IP address, subnet mask, and the default gateway. From there, you are ready to go, and next step we will connect to the programming software or engineering software for programming purposes. So this device uses the GOC toolkit, which is part of the Codesys programming platform. It is an ISC supported platform and accommodate all the ISC PLC programming languages such as structured text, instruction lists, function block diagrams, ladder diagrams, and so on. It is an integrated tool since you are able to configure both your HMI program and your PLC program via this tool. So it is very handy and portable tool, and it's free for download, which can be accessed via our website. Links will be provided, and also it will be available on the Mitsubishi knowledge base from the Adroit website. So if we look at the GOC HMI function of this unit, we will see that the HMI part can be found on the front side of the GOC, whilst the PLC part will be found at the back of the GOC. Okay. So if you look at the HMI part, it's got an LCD screen, and it's got a 10 keypad navigation and data entry set of keys, which are programmable, but it's not recommended to program them. Also, it's got 8 illuminated keys, which can both accommodate user interaction as well as provide status indication via LEDs, which utilizes 3 colors as well as blinking speeds to provide different messages to the end user. As mentioned, the 10 key keypad can be used for navigation, like home, back, up, down, next, and enter, as well as it can be used for numeric and alphabet, in other words, alphanumeric data entry onto the LCD screen. The right hand side of the GOC shows the 8 illuminated keys. Okay, these can be programmed with different LED control outputs via a control byte, okay, which of course will provide you a combination of blinking and colors. There's about 10 options for that, 10 variations that can be used. Okay, here we've got another view of the functions of the HMI of the GOC. I want to point out that on the top left corner you can see 2 indication LEDs. So you have the power LED and the run LED. These will provide the status of your PLC and HMI on the GOC. So in other words, if there's no power, obviously you will see it via this indication LED. But if there's power and the PLC is not running, you'll also be able to see that. So obviously both those indication LEDs needs to be activated for a healthy GOC. So more information about this HMI component of the GOC is that it can accommodate up to 64 screens. Okay? So these screens can be used in combination of various requirements of the process, like you can monitor certain equipment, alarm messages, machine status, also process status. It can also allow the user to set application data. Okay, all of these can be configured via the HMI configuration tool, which is a part of the Codesys software. We will be looking at that in detail in part 2. Okay. So some of the functions that you can apply to the GOC HMI is timers, counters. You can monitor temperatures. You can control machine speed. You can use it for production purposes, running hours of machines for maintenance purposes, and also for alarming and data logging. It must be pointed out that the GOC HMI accommodates predefined graphic elements only, with a single color. For more advanced graphic requirements like VGA colors or user-defined graphics, a GOT symbol is recommended. Okay, so for this GOC PLC function, as can be seen, you can utilize various programming languages. As stated earlier, IEC programming languages. So the most common ones in the process and factory automation industry would be your ladder diagrams and your function block diagrams, which will be included in the scope of this presentation. However, since these are IEC programming languages, you can use them in a mixed way. They are intercompatible, and we will have an example of that where we will use function blocks in ladder diagrams. If you look at the programming environment, this is just a short summary. At the top, we've got the variable declaration field. So here we will add all of the variables which will be used in the PLC program. Okay, like tags and also the data types will be listed here. We have elaborated on this later on in part 2, and it will make sense at that stage. Below that, we will have a programming area. Okay, so these are programming sections. Depending on the programming language which you use, you will have networks, or it would be one field. In this case, it's networks because we are using ladder diagrams. Below that, we have the software output display. So this will be your status of your programming process or your controller, as well as the condition of your program written, in the sense of errors and warnings. Obviously, it's a prerequisite feature. So one of the strengths of this Codesys toolkit, GOC toolkit, is that you use one platform to configure all of the hardware components, which will be your PLC configuration, PLC programming, HMI configuration, HMI programming, and as well as the integration of these two functions with each other. As you can see, the different areas where this will be done. The PLC programming area will be done in this tab here, which is the one that's open. HMI configuration will be done in this tab here, and the hardware configurations can be found here. If you look at the back of the GLC, in the configuration toolkit, you will see that there are many slots that can be used to configure your hardware to your process requirements. So if you look at this area here and this area here, you can add option adapters. So these can be your digital discrete I/O, analog continuous I/O, as well as high-speed counters, which can be added in there. These two slots here, as mentioned, are used for your communication modules, okay, Ethernet and serial. Below that, you will see a table of this digital discrete I/O. This is where you actually declare each one of your digital inputs and digital outputs, giving it a name as well as access its address, which can be used in the PLC program. Okay. So here's a complete GLC unit where all of the fields are utilized with option adapters and cards. So as you can see here we've got a 4-channel analog input, 4-channel analog output card, RS422 communication card, RS232 communication card, and then of course you also have the built-in I/O, digital discrete I/O, which is your inputs on the top here, outputs at the bottom here. So your outputs, you can have two types, relay and transistor. Your inputs also accommodate two configurations, sink and source. In addition, you have your powering socket here. This particular unit powers a 24-volt DC. And on your right hand side, you can see there's a slot for your SD card, which is used for logging or data storage purposes, or memory value storage purposes. So when you open Codesys and you start compiling your program, you will find that there are various of functions. The functions that we will be interested in will be pointed out in the next few slides, as these are the minimum requirements to get your GLC program. In this particular case, we see that you need to build your program prior to program your GLC. It's basically a program compile, and your GLC will not be allowed to be programmed if there's any error in your code. That is one of the prerequisites. Okay. Here we see more functions that we'll use in this scope of presentation. First of all, on the top, you've got your login and logout. That's basically connecting to your GLC and disconnecting from the GLC, okay, for monitoring purposes and programming purposes. And below that, we've got your run and stop. That's basically your PLC stop and run mode that can be set there. If the PLC is in run mode, then you can test and simulate your program. If it stops, then nothing will happen. Below that, we've got your write values. So whenever you force a data entry or set a bit, the GLC will not accept that change until you write the values to the GLC. Okay. Below that is your simulation mode, which is handy if you want to test a program or test the engineering software, in this case this, or test the functionality that you can use with this product prior to purchasing it, as you don't need any hardware for simulation mode. This will be purely software. Okay, so now we are going to discuss part 2, which is the demo. Okay. So here is an example of a pre-programmed GLC. The program that's on a pre-programmed GLC. Okay. A small program which we've written just to point out some of the functions which can be used in the plant. As mentioned, the top part will be your variable declaration field. You will see all your tags as well as your data types, okay, being pointed out there in detail. On the left here is your program files. which will be programmed onto your GOC. This particular one is a ladder, as you can see from that symbol there. You don't need to write all your program files with the same language. You can mix them up. Remember, these are IEC programming languages. So you can write various of programs and sections below this unit here. You can just add new program files. Since this application which we are demonstrating is a small one, we'll only have one program file. So here, the programming field, you can see ladder diagrams are being used. The classical normally open, normally closed gates, as well as your coils. So you have your normally open, normally closed contacts and your coils. Note also that you add function in between. You can use that, like the timers, your counters. You use scaling blocks. You use comparison blocks. You can use a wide range of predefined function blocks for your process. Below, your project system messages. So here it gives you the status of your hardware as well as the condition of your program. Recall that the program needs to have 0 errors prior to compiling, prior to programming the GOC. Right. Okay. So since this HMI is combined with a PLC, you can obviously add I/O hardware to your unit. In this case, we will have a simple stop and start circuit as your digital discrete inputs to demonstrate some of the functions inside of this GOC unit. Also, the illuminated keys, the 8 keys here, the 2x4 matrix keys on the right hand side of GOC, which is part of your HMI. Note the digital input statuses, the stop start, also the digital output status, which is your running. Okay. On the left hand side, we also have the raw analog values as well as scaled analog values. So in other words, what we are trying to point out here is that the GOC can accommodate advanced analog value calculations, manipulation, like scaling, comparison, mathematical functions, etc. Okay, so the next image we'll be looking at will be the video. So just showed what we achieved here. So here we are demonstrating the navigation functionality of these keys. You can see the pump is stopped, and the buttons are off. Some basic symbols that can be added to this GOC unit. Okay, so if we activate the physical start switch, the pump will, in the simulation, activate and start filling the tank with liquid. So here, this value is not a percentage value, it's a liter value. So this is we use this configuration to demonstrate the tank level conditions. So here we see the tank level is healthy, green light. As soon as a certain level is reached, like 50% of the tank, then the yellow blinking light will activate. And as soon as the levels are at the undesirable level, like overflowing, in this case, the red indication LED would blink fast. As you can see in the case here. So we stopped the pump now. This can be done automatically, obviously, part of the program. For the scope of this demonstration, we opted for the manual activation because we don't have a physical tank here. Okay, levels are healthy again, and all the indication LEDs are deactivated. Okay. So just want to show the monitoring of the PLC program via the SCADA programming platform. As can be seen here, the variables in the variable fields are updating, as well as the function box, the values in the function box. You can see it's dynamically updating what's happening currently. So next video, so this is a close up of the GOC HMI screen output. PLC program. So another advanced feature of this GOC is the simple visualization. So simple visualization is basically a built-in SCADA feature in codices, which allow you to build a simplified SCADA in a platform just for monitoring and testing purposes. The SCADA is very basic. It's not intended for industrial use at all. It's just for monitoring, troubleshooting, and confirming certain operations in your PLC program. But it cannot be used for plant SCADA purposes, especially advanced plant, large applications. As you can see, it's quite dynamic. So this is basically the two parts of the presentation which we want to cover in this presentation. Some supplement information will be made available in our Adroit Mitsubishi knowledge base as a knowledge base article. This usually includes procedure videos, sample programs, compiled notes, all the frequent asked questions can be found in the knowledge base. It's important to point out that this knowledge base is not static. It expands continuously as queries arise and attention is required in certain fields of the factory automation hardware. Okay, so thank you very much for your time, and I hope that you have learned something in this presentation. If you did, please like and subscribe if you didn't subscribe yet, and also you can click the bell for notifications for future videos being posted. If you've got any questions, please drop us a mail. You will see the mail in the previous slides at the bottom, and we will attend to it as they come in. Thank you very much.